This video is about balancing
Equation.
Balancing equations is based on a law called the law of conservation of matter or mass. And that basically means that atoms cannot be created or destroyed, so they won't disappear. If you look at this equation, you can see that you have one hydrogen molecule, one oxygen molecule, and one water molecule. So the question is, does this equation happen in real life? So if I put pictures here, so according to this picture, you have one H2 made of one hydrogen and another hydrogen. Another molecule made of two oxygen atoms gives you one water molecule. According to this equation, one of these oxygen atoms completely disappeared. Does that happen in real life? No, because it doesn't obey the law of conservation. It doesn't obey the law of conservation. So what actually happens? In real life, this equation happens with two hydrogen molecules, and it also forms two water molecules. So if we count the atoms on either side now, and we say, how many hydrogens do we have and how many oxygens do we have? Okay, we should get the same number. So how many hydrogen atoms do we have on the left?
4.
How many oxygen atoms on the left?
2.
Good. That's my B6 class. How many hydrogen atoms on the right?
4.
And how many oxygen atoms?
2.
Now, because we can see that there isn't any atom that has disappeared, this reaction is called balanced. And to show that it's balanced, we use something called coefficients, where we count the number of molecules and we say, okay, we have two hydrogen molecules, and each hydrogen molecule has two atoms. And on the right hand side, we have to count that we have two water molecules, and we put the number 2 in front of the H2O to show that you have two water molecules. Okay, so let's start with this reaction. I'm first going to make my list. And now I'm going to count. On the left hand side, I have two hydrogens and also two chlorine atoms. On the right hand side, I have one of each. Now, according to the law of conservation of matter, these two things need to be the same. In other words, the number of hydrogens on the left hand side must be the same as the number of hydrogens on the right hand side. So we don't see that happening right now. So we can change the number of molecules of HCl that we have. So if I put a 2 in front of this, I'm saying I have two HCl molecules, which means now I have, instead of one hydrogen atom, now I have two hydrogen atoms. And instead of one chlorine atom, I now have two chlorine atoms. And because these numbers are the same, I can now say that the reaction is fully balanced. So this one is a good example because it has some polyatomic ions. And in order to do the polyatomic ions, you have to separate them, just like we've been doing one element at a time, right? So you're not going to put, so this is a hydroxide ion, right? And you're not going to put the hydroxide as a polyatomic ion on its own. You're going to split it up. So who can tell me which two elements make up hydroxide?
Oxygen and hydrogen.
So now we have K and oxygen and hydrogen, and we also have sulfur. And if we count the number of potassium atoms on the left, it's 1. Oxygen over there, I'm going to count 1 plus the 4 over there. So altogether that makes 5, good. And then hydrogen, I have 1 over here plus the 2, and that gives me 3. And I have 1 sulfur atom. On the right hand side, I have 2 potassiums, and I have 5 oxygen atoms and 2 hydrogen atoms and 1 sulfur atom. So the first thing that we can't get away without changing is the fact that we have 1 potassium atom on the left and 2 on the right. Balancing is a game of trial and error. So the first number that you try might not get you the right answer immediately. So I'm going to try to get my potassiums to be the same by putting a 2 in front of the KOH. So that means I now have 2 potassiums, 6 oxygens, and 4 hydrogens. And so that means that my potassiums are balanced, my oxygens and hydrogens are not balanced now. So the number that I'm going to put in front of water is that I can see I have 2 hydrogens, but I need to get it to 4. So that's why I'm going to put a number 2 in front of that. That means I have 2 times 2, which is 4. And now I also have 2 oxygens, because there's 2 water molecules, which means I have 2 oxygens, plus the 4, that actually gives me 6 oxygen molecules, oxygen atoms. And now I have 2 potassium atoms each on either side, 6 oxygen atoms on either side, 4 hydrogen atoms on either side, and 1 sulfur. So now that reaction is also balanced. Okay, for this one, we have 1 aluminium atom on the left and 2 oxygen atoms also before the reaction happens. And then after the reaction happens, you have 2 aluminium atoms and 3 oxygen atoms. Now, when you have 3 oxygen atoms and a diatomic oxygen, you can try to get them have a common multiple. And the common multiple of that is 6. So in order to get the oxygen to 6, I'm going to multiply that one by 3 and multiply this one by 2. So that makes it 6. That brings my aluminium to 4. And the nice thing is that this aluminium atom is all alone, so I can just chuck whatever number I want to in front of it and it will match up. So if I put a 4, it will immediately change to 4. And that gives me a balanced reaction there. Okay, if we start on this reaction, we see we have 4 phosphorus atoms and we have 10 oxygen atoms in this molecule, but we have to add that one because it's still before the arrow. So that gives me a total of 11 oxygen atoms and 2 hydrogen atoms. Now on the right hand side, we also have a polyatomic ion. This one is called phosphate, but we have to separate it into the atoms that it's made of when we are balancing. And so if I'm going to try to balance, again, I don't have a choice. I have to get this phosphorus on this side to be 4. So I'm going to use that as my guide, the fact that I need 4 phosphorus, and see where it takes me. Like I said, you have to do trial and error, right? So if I put a 4 in front of that, that means I have 4 phosphorus atoms now instead of 1. And I also have, I'm going to say 4 times 3. So I also have now, instead of 3 hydrogens, I now have 12 hydrogens. And instead of 4 oxygens, I now have 16 oxygens. Okay, so on the left-hand side, we have 11 oxygens over here. On the right, we have 16. Okay, so we have 10. Now, we can't add a number in there, but we can add 6 of this. So if we put the 6 in front of here, the 10 plus 6 oxygens will get me to that number 16. So the second round of numbers I can do is put a 6 in front of that hydrogen. That will mean now I have 10 plus 6, which is 16 oxygen atoms. And now I have 12 hydrogen atoms. And so as you can see now, it is balanced. And if you're going through that worksheet, the one way to check that all your answers are correct is to see if you have these numbers equal on both sides. Okay.